Algebra 2, State Regents sample question number 3. The expression 6x cubed plus 17x squared plus 10x plus 2 divided by 2x plus 3 equals what? Multiple choice. So this is a division question, and you learned a couple of different division methods on how to solve this. At first glance, you could potentially factor and hope that there's a common factor of 2x plus 3 that gets crossed out, but that's not happening here. You see up here, up top here, that definitely can't be factored. Let me zoom in a little bit. Um, so it's definitely division. It's, top divided by bottom. That's what fractions really are. They're, mini division problems. So we have to use a division method here, and you learned maybe a couple. You might have learned reverse tabular or long division, and everybody's favorite synthetic division. But synthetic division, it's not really great when there's a remainder. It's actually good for finding the remainder, but synthetic division is really a tool for doing one of two things: determining if something is a root, and if not, what's the remainder. But it's not great at finding the quotient, the answer through the division. And maybe I'll do some synthetic division here for you after I do maybe long division. And I'll show you why one method's really better than the other. So let's do long division here. And long division is really a tool you definitely want to have ready in your arsenal for this course and this region. So I want to show you long division because I think that's probably what's going to be the most useful to you going forward. So long division, 2x plus 3 is the divisor, and the dividend 6x cubed. Now, whenever you're doing any type of division, you always need to make sure that you don't have any gaps in the exponents or holes. And I start with an x to the third term, and then I have an x to the second term, and then an x to the first term with 10x, and then I have a constant 2. So I don't have any gaps here, but say I was missing this x squared term, and it went right from x cubed to x to the first. I would want to put a 0x squared there, kind of fill in the gap, fill in the hole, because it becomes a problem for a lot of the division methods if you don't recognize that gap and plug it with a 0. But anyways, we're good here, so we could jump right to the division. Long division is a repeating process. And it starts with just division, but you don't want to think about this whole thing divided by this whole thing. No, we want to think about just the front divided by the front. So 6x to the third divided by 2x. That's the only division I want to think about, the front divided by the front. And 6x cubed divided by 2x is 3x squared. 6 divided by 2 is the 3, and x cubed divided by x is x squared. I want to put that in the x squared column. I don't want to put my x squared quotient here. Everything's going to be lined up. All the x squared terms are going to be here, all the x to the first terms, and so on, so on, so on. So it is 3x squared. 6x cubed divided by 2x is 3x squared. So the first step is to divide. And we're dividing front by front. Then, second step is to distribute. I distribute 3x squared to the entire divisor, not just the front now. I multiply it to 2x. 3x squared times 2x is 6x cubed. And I multiply it by 3 to get 9x squared. And so I'm going to be working in binomials here. Because my divisor is two terms, I'm always going to work with two terms, and then I'll work with another two terms, and I'll work with another two terms. So I'm going to be working in binomial pairs here. If this were a trinomial, then I'd be working with three terms at a time. So you always work it, because that's what happens when you distribute to 2, you get 2. So this was 9x squared, 3x squared times 3. All right, so I divided the front by front, then I distributed. Next, I change the signs. What I mean by that is I change the signs down here because I need to do top minus the bottom. And a good way to subtract a polynomial is to change all the signs of the polynomial that's being subtracted. And the front terms will then cancel out, and that's a necessity. If that doesn't happen, then you already made a mistake somewhere. 17x squared minus 9x squared is 8x squared. Okay, so we changed our signs, then we combined terms. So we divided, we distributed, we changed, we combined these together to get 8x squared. Now I want to move down my next piece, so keep it in the same color, 10x, and repeat the process. Divide, distribute, change, combine, repeat. And I'm bringing down only one term because I'm working with with binomials here. Again, if this was a trinomial, I'd bring down the next two terms, or however many I need to make it a trinomial. So we divided, we got that. We distributed to get that. We changed its signs, and then we combined to get this. Bring down a piece. Now I'm going to repeat the process. I'm back to dividing. And again, I'm dividing front by front. I'm no longer looking up here for my division. I'm looking at my new things down here. And it's still just the front divided by the front. So the front of this divided by the front of this. 8x squared divided by 2x. 8 divided by 2 is 4. And x squared divided by x is x. So it's 4x. Distributed to both of these gets 8x squared and 12x. Then I'm going to change my signs. Positive terms go to negative, negative terms go to positive. These cancel out. 10x minus 12x is negative 2x. Bring down the next and last piece, plus 2. I divided to get this. I distributed to get this. I changed my signs and combined to get this. Bring it down. Repeat one more time. And I repeat until I'm out of terms to pull down. I pulled down the last term, so I know I just have one more round left of the division. Front divided by front again. And negative 2x divided by 2x is negative 1. Distribute it becomes negative 2x minus 3. Changing signs. This time they're negative, so they'll change to positive. And whatever it is, if it's, it could be one of each. In this case, it was two negatives, two positives, but it could easily be one of each. These cancel out. 2 plus 3 is 5. And this 5 is really, really important because it is the remainder, but it also tells us something about the problem. It tells us that 2x plus 3 is not a factor of 6x cubed, so on, so on, so on, so on. And that's something called the remainder theorem, that if this was a factor of this, then I would get a remainder of 0. So the remainder of 0 is what we want, because that means it's a factor, which I can then turn into a root or a solution or a 0, different names for that. But if I don't get a 0 here, that means this is not a factor. It doesn't divide evenly. It's not a factor, but I could still express the answer a certain way. I could take this remainder of 5 and add it to the end of the quotient, but it has to be over the divisor 2x plus 3. Because I still have 5 left that needs to be front divided by, this. I need to do 5 divided by this, and that's what's left over. But I can't do that anymore, so I just write it then as a little division problem on the side. So our answer is 1. All right, really quickly, let me give just a quick explanation here as to why synthetic division is not the option to go with. First of all, synthetic division only works if this is degree 1 down here, which it is. If this was an x squared, x cubed, synthetic division would not be an option. But this is, I'd have to, kind of set it equal to 0 and solve it because we use roots for synthetic division, not factors. And so it would end up being negative 3 over 2. And then I would have 6, 17, 10, and 2. And let me run through the synthetic division really quickly. Bring down the 6 times negative 3 over 2. It's really times negative 3 divided by 2, or I could divide by 2 first and then times negative 3. Either way, same thing. Divided by 2 is 3 times negative 3 is negative 9. They combine to be 8. Divided by 2 is 4 times negative 3 is negative 12. They combine to be negative 2. Divided by 2 is negative 1 times 3 is 3. And I still get that remainder of 5. That's why synthetic division is still very useful. But the problem is, because I started x cubed, you would think this then goes x squared plus 8x minus 2, remainder 5. And this 6x squared plus 8x minus 2, that might make you think the answer is here. I have a remainder of 5, 6, 8, negative 2. That looks pretty good. So why is this not the answer? Why is this the answer? Why is 1 the answer? Well, because synthetic division has its most value in finding this remainder to tell us if this is a root, if this is a factor, if we get a 0 there, or if not, what's the remainder. Because synthetic division is a little weird, it has to do with, notice that this is the answer, but times 2. And that has to do with because our synthetic division is being divided by 2. So all of these numbers then need to be divided by 2. So there is a way to use synthetic division, but I feel it's very complicated and has a lot of risk involved in it. If it's just what is the remainder, or determine if it's a root, or determine it's a factor, one of those type of questions, then synthetic division is great. But if it actually wants to know the quotient and remainder and everything like that, long division is a much safer way to go, in my opinion. So you could do both, but I definitely recommend long division here because I think a lot of students would be tempted to choose the wrong answer because they don't fully understand that when you do synthetic with a fraction, it doesn't really give you the completely full picture of what the quotient is. It's just really great for finding the remainder. All right, so that's a great example of long division and how to express the remainder as part of the quotient. And what we found is that this answer, whoops, didn't mean to move that D. If we take this answer and multiply it by this, then we get back to being here. And that's really the key for division is finding the quotient. All right, see you.